In this session, we are going to learn what is called this ADMET analysis: absorption, distribution, metabolism, excretion, and toxicity analysis of the synthesized compounds. We know that whatever the drug is given to the patient, that will enter into its body, it will be absorbed through the several membranes, and then it will be distributed to various compartments of the body. These compartments, we know there are cellular membranes, body fluids, blood, connective tissue, lymph, saliva, and cerebrospinal fluids. There are so many compartments of the body. So it will be distributed among these compartments. Then in these compartments, in these several tissues or body fluids, this drug will be metabolized. The metabolism of the drug may be possible in the form of oxidation, reduction, or there are so many methods for metabolism of the drug. Generally, there are two kinds of metabolism: phase 1 and phase 2. So phase 1 is basically kind of procedures or some steps where oxidation, reduction, hydrolysis, this can occur. Phase 2 is a process of metabolism where conjugation generally can occur. And this conjugation, which can be, let us say, some kind of glucuronidation, acetylation, and so on, right? So there are so many other methods for this, for phase 2, which is basically phase 1 will get the conversion of the molecule into the polar one, and then these polar molecules will be conjugated through the process of conjugation with the conjugating substances into the body, and then it will be excreted. This excretion can be in the form of majorly urine, or it can be defecation, or sometimes this drug can be also found in body fluids such as saliva, lacrimal fluids, and whatever. There are many other secretions in that can be present. Then, if some amount of drug which is not removed from the body, it is going on accumulated slowly, then it can cause toxicity as well. We know this toxicity which can lead to some side effects. The previously patient was given certain drug, it was found toxic, now it has caused another disease, right? So just like we are aware about the recent pandemic, where during COVID-19 pandemic, this steroids were given to the patient. An abundant use of steroids to the patient have caused later on mucormycosis. So that is one of the reason for the cause of mucormycosis. So that is basically toxicity. Not only the steroids, but also the impure oxygens have been also, we have referred many newspapers in which it is mentioned like this. So in this session, we are going to discuss what are these ADMET properties and what are the basically this, how can we calculate them. So you have been already taught in some different session how to calculate Lipinski properties, such as hydrogen bond donors, hydrogen bond acceptors, this molecular weight, permeability, partition coefficient log P, and one more parameter, what is called this number of rotational bonds. So these you people have already learned in the previous session. Similarly, we can calculate these properties, which are nothing but called as ADMET: absorption, distribution, metabolism, excretion, and toxicity. In silico tools are available where we can calculate such properties, which are also called as ADMET, written as ADMET. Now, what are these ADMET properties? So what parameters are there? We can calculate these parameters. I will show those parameters to you pertaining to absorption, distribution, metabolism, excretion, and toxicity. So looking at the structure of the molecule, one can predict such properties such as volume of distribution, which is one of the distributing parameters. From log P, we can calculate the permeability. On toxicity, there are certain skin sensitizations. So all other toxic parameters we can calculate. For excretion, we can calculate what shall be the clear rate of the clearance. So there are so many parameters are there. And these can be calculated with the help of several tools. So some of them are free, some of them are paid. Very widely used tools are QuickProp. QuickProp is one of the module of Schrodinger, which is generally a paid software. There is another software, so CSAR or somehow StarDrop. These are basically from Zastra Innovations. So they are also allowing us to predict such properties. So I know these two softwares which are paid softwares. One will have to pay for getting the license for limited amount of time. We'll have to pay some money. There is another software. Now I'm going to discuss the free softwares. Mole Inspiration, which people have seen, which you have used in some different session to calculate Lipinski filters. So that software, this tool, which is available online freely, and you can calculate all those 5 different properties of Lipinski's rule of 5. There is another tool which is called PKCSM. I'm going to give its demo to you people today for calculation of this ADMET properties. Another tool called Swiss ADME, that is powerful tool to calculate the properties, this ADMET properties. Lipinski properties, Weber rules, Gauss rule, Moore's rule, all these rules we can calculate with the help of this. And also Boyle-Dag model, which was developed by two different scientists for calculation of brain permeability or permeability to central nervous system. So this already people have calculated using Swiss ADME. So that I am going to show it to you people today. Okay, so I'm going to show this to you so that hopefully it will be visible very soon. Right? So how do you have to search? You simply click on Google, and this is your Google window. You have to type here Swiss ADME. So there will be several lists on your screen, and you can predict this and jump to click on this Swiss ADME. So Swiss ADME T shall be there. This is the window for this Swiss ADME. It was developed by Swiss Institute of Bioinformatics, and this is a literature which is available in Science Report, which is you can go to this one, download this one, and free web tool to evaluate the drug likeness, medicinal chemistry friendliness properties of molecules, especially small molecules. Right, so that is for this, and this is a workspace for this software. How you should use this software? Here there are so many tools. If you wish to draw your structure, you can draw with the help of several tools. Right? Here is a benzene ring, cyclohexane, pentane, in whatever imidazole, nitrogens, and 5-membered cyclic rings are there. These are the several atoms. If you click on here, your periodic table will open up and you can make the use of the same thing for your purpose. If you don't require it, just click somewhere, it will disappear. And if you do not want to draw the molecule, just like you are doing in the ChemDraw, then in such case you open, so if you have some file is with you, but remember the file format should be STF. Okay, so I'm selecting one of the file which was with me, so then I'm opening it, so I can see I do not need to draw the molecule on this workspace, it is already available there. Just single click will fetch that molecule, provided molecule should be stored in your STF file. So now you click on this button so that it will transfer your sketch structure, your open structure into the smiles. So you can see this smile is there. This is actually a kind of representation, a kind of linear formula, a kind of schematic molecular structure. And it's not like the smile which we are smiling, but our kind of smiles, but it has full names. Like I can show it to you. If you search on Google smile full form, you will be able to see it is a kind of simplified molecular input line entry system. So this is the way where we can code all these nitrogens, all carbons, oxygens. So that is basically a linear formula, right? So this is advantage that you can code any molecule in a simple linear formula, right? So that is the kind of simplified molecular input line entry system, SMILES. Then simply you click on run. So I'm going to demonstrate you people what shall be this properties for one molecule. So moment I click on run, you can see that several properties are there on your screen here. The physicochemical properties for your molecule. That lipophilicity. This is somehow bioradar map where you can calculate this water solubility, pharmacokinetics, drug likeliness, medicinal chemistry properties. So all this can be calculated with the help of single click. You know what is called formula? Molecular weight, number of heavy atoms, including nitrogen, then number of aromatic heavy atoms, some other properties which we discussed previously, number of rotational bonds, hydrogen bond acceptors, hydrogen bond donors, molar refractivity, and topological surface area. What are called hydrogen bond acceptors? Many of them pharm students, even they don't know what is called hydrogen bond acceptors. Hydrogen bond acceptors are electron donors. Electron donor can be nitrogen, oxygen, sulfur, halogens. So these can be hydrogen bond acceptors. Hydrogen bond donors are always electron acceptor. So wherever you see a hydrogen atom attached to nitrogen, oxygen, fluorine, or halogen, so that is termed as hydrogen bond donor. So दोनों में फर्क है. Hydrogen bond donor is electron acceptor. Hydrogen bond acceptor is electron donor. So nitrogen के पास दो lone pair है, sorry एक lone pair है. So that lone pair is available for donation. So that's why it is hydrogen bond acceptor. It is going to accept the hydrogen bond. फिर आप अमोनिया का जो हाइड्रोजन है, 3 हाइड्रोजन है अमोनिया में. So that hydrogen is attached to nitrogen. But this hydrogen can accept the lone pair from other electronegative atom. That's why it is electron acceptor. Electron acceptor is always hydrogen bond donor. So this way you can understand the concept of hydrogen bond acceptor and hydrogen bond donor. So acceptor, that should be not more than 10. Donor should be 5 or less than 5 or not more than 5. These are other properties. Molar refractivity, one can calculate this with the help of Abs refractometer. TPS is topological polar surface area. It is said that molecule should have polar surface area not more than 140 angstrom square. So that is considered as important. Lipophilicity, we have previously discussed this in some of our theory session. Several types of lipophilicities are available depending upon their formula. So you can see that moment I place my cursor from one log P to other log P, it is showing some properties. Water solubility, log S, Ali log S, and this silicose IT, ESOL, so all these they have been mentioned in so many references. So from that it has been implemented. Pharmacokinetic properties, GI absorptions, according to the Boyle-Dag model. So it can predict us whether it is low, high, or no. So all this we can predict. Then we can predict metabolism also, whether it is going to CYP enzyme inhibitor, yes or no. We can predict this is not going to inhibit the CYP enzymes, CYP2D6, CYP3A4. So that's why it is mentioned no. Drug likeness, we can very easily predict this one, that how many molecules of Lipinski rule of 5 are there, whether they are followed or not. So here it is mentioned. Molecular weight less than or equal to 500, log P is they have mentioned 4.15. Okay, so all of them are there. Gauss rule, what is Gauss filter? It is given in the publication of Journal of Combinatorial Chemistry in the year 1999. So these properties are mentioned. Then Weber's rule of 5, Weber's filter, which is from GSK filter, GlaxoSmithKline. So you may be working in GSK. Lipinski was working in a Pfizer, so that's why it is called as Pfizer filter. So Weber was working in GSK, so it is published in JMed Chem 2002 paper, right? So it consider only rotatable bonds and topological polar surface area. Agon's rule, basically W log P and topological polar surface area, only two are considered. Then Muget's rule or some Bayer filter. So you can consider not only number of rings, a number of carbon atoms, so many other things are considered. So depending upon this, it is mentioned here whether it is followed or not followed. If not followed, then how many violations are there and why? Because molecular weight is beyond this. It is, we can predict. I'm not going to discuss these properties, but this is more important. Pains. Basically, this is pan-assay interferon compounds. There are certain compounds which are having all the kinds of activity, such as curcumin, which is obtained from Curcuma longa. So that curcumin is this kind of compound, pains, which is having universal activity, anti-inflammatory activity, anti-TB activity, anti-malarial, pro-immunomodulator. All those activities are considered against pains compound, pan-assay interferons compounds. Many good journals, they rely on this, but whether will it be a better compound or not, or does it belongs to pain or not? So this is a new science developing. I will not go into the depth of this, but this software also allows us to predict whether it is a pains or not. So this you have predicted using Swiss ADME for only one molecule. You can predict this for large number of molecules. Let us say instead of bringing one molecule, let me delete this one from your workspace, and I wish to perform the similar analysis of 10 molecules. So what I have to do, I have to copy this, choose the file, have to select all these 10 compounds together, right? All of them are, no, I will have to open them one by one. So this is mole 1, enter. So now I will open mole 2. So let me do it for 5 molecules for demonstration purpose. This is mole 2, and it's, you can see it is having the SMILES formula, which is different for this one, right? So now the third molecule I am going to show, that is basically mole 3. So this is mole 3. You can see the linear formula is there and totally different. Now another molecule, that is mole 5. So this is mole 4, sorry. So you can see the fourth is also entered. The another one is mole 5. So I'm going to demonstrate for this and opening that one, transferring it sketch structure into the SMILES. So total 5 molecules and 5 SMILES have been generated. I will click on the run. The moment I click on the run, you can show at the progress over here that slowly they will calculate all these molecules, molecule 1, molecule 2, 3, 4, and 5. And thus, all these 5 properties will, all the 4, 5 molecules will be calculated. Now we can have this data. This important feature of Swiss ADME tool is that once you click on this CSV file, the option available here, if you click on that, the advantage is that you can export all the properties of 5 molecules using this Swiss ADME. Right? This is basically a comma separated values CSV files. Open it and click on that. The moment you open it on your Excel, the advantage is that you will have, let me browse it and I shall try to open the file which is on my desktop. All files now I can see in the form of ADME. So whatever the molecule I have taken, mole 1, 3, 4, 5, all these properties are exported in your Excel file. Now you can make the use of them, right? For whatever purpose, you can sort, dissort, you can, if you do not wish some properties, you can eliminate. In all the functional tools of Excel, you can perform. Okay, I'm going to change the file extension to Excel file or Excel workbook. Okay, so now this, you can have this file with you for your purpose, and you can present your data this form. There is beautiful module of this, that is show boiled egg. This is a, you can easily calculate the boiled egg model. Why it is called boiled egg? Because if you look at to this one, the structure of the same is looking like an egg. Maybe it is visible. That it is having certain blue part and certain white portion, certain yellow portion. This is looking like an egg, and this is a yellow portion. So yellow portion indicate it is having blood-brain BBB permeability, blood-brain barrier. This white is basically indicating human intestinal absorption. The Joby compound, this is molecule 2. So that is easily absorbed. This is actually molecule 4 and molecule 5, which can easily permeate blood-brain barrier. This blue circle, which indicate it is going to inhibit this P-glycoprotein plus, and the red circle indicates these molecules are going to inhibit, these are going to promote the P-glycoprotein, which is one of the efflux pumps situated in the cell membrane. And this efflux pump will pump out the entered molecule from the cytosol or the inner cellular membrane. So red are going to inhibit and plus are not going to inhibit. So that is you can predict. Okay, I may not have shown this previously export X6 Excel file because I have not shared the full screen, but yes, this way you can calculate, export this Excel file can be with you and you can export it. Okay, so that I basically wish to discuss with you people regarding your Swiss ADMET. So after Swiss ADME, so all these properties once you can calculate, there is another tool I am going to demonstrate to you people, and that tool is called as PKCSM. This is also free tool which is available online. Type on Google PKCSM. Previously I have searched, so it is there in my history. Enter. The very first link is there in front of you. Click on that. It is similar tool just like your Swiss ADME and Mole Inspiration. Here friends, all this is a publication of the Journal of Medicinal Chemistry 2015, where the whole paper was there on this PKCSM tool. It was developed by University of Melbourne, University of Cambridge, and this some other university. Right, simply click on here predict. There is an option called predict. You click on that. So this window will open up and you shall need here your smiles. Okay, so whatever the smile you have generated with the help of Swiss ADMET, you put over here. I'm going to use one of my smile which I have used previously because it is there in my search history. You click on that, so that is selected. Otherwise, you open up this CSM Swiss ADME and convert the molecule to your this one and generate the smiles, and then you can copy that generated smile. Likewise, this. Let me demonstrate you people for as you are learning today itself. So open the molecule one, create a smile. So copy this smile, put it there in PKCSM in this search box. Okay, you have put it over there. Now you just have to calculate all these properties. If you click on this blue button, it will calculate absorption, similarly distribution, metabolism, excretion, and toxicity for this blue, light blue, light green, orange, or pink buttons respectively. And if you click on ADMET, the black color button, it will calculate all the properties. It will take time. This is actually maybe time taking tool, and you can see here these all absorption properties, distribution properties, metabolism, excretion only to total clearance, and renal clearance, OC2 substrate, and they are being calculated. Some of the parameters are qualitative parameters. Answer will be yes or no. Whether it is inhibitor, yes, no. So that kind of qualitative answers. Some other properties are quantifiable, such as water solubility. It can be quantifiable in log of mole per liter. Kappa2 permeability, which is important for cell permeability. Kappa2 is basically name of the cell lines. And if you wish to calculate the permeation power, permeation caliber of the compound, Kappa2 cell lines, Kappa2 assay can be performed. Intestinal absorption. So one can calculate whether it is being absorbed through human body or not. Skin permeability, P glycoprotein substrate, whether it is yes or no, whether it is P glycoprotein 1 inhibitor or not. So that we can predict. Volume of distribution during a steady state plasma concentration, steady state achievement. So we can calculate this one. Fraction of the unbound protein, unbound drug, especially FU, we can calculate this. BBB permeability also we can there. CNS permeability. So all these parameters we can calculate. Not only absorption, distribution, metabolism properties, whether it is going to inhibit the CYP enzymes, yes or no, we can estimate it. Excretion rate, total clearance, what is the total clearance of this? One can predict. And toxicity level, so bone marrow toxicity, skin toxicity, hepatotoxicity, all these are several properties, toxicity properties, one can predict. Whether it will be causing skin sensitization or not, so one can also predict this. But that limitation of this PKCSM is that you will not be able to export the same thing using a single click. Swiss ADME allows this. Click on that, it will be exported. But for PKCSM, it is not done. So what you have to do, you will have to open the Excel sheet and will have to type one by one. Water solubility minus 0.721, type there in your Excel file. Whether it is P glycoprotein, yes, type it in your Excel file. So this way you will have to type to make a sheet of all these properties for your compounds. In this way, you can predict all these ADMET properties. The same can be calculated with the help of different softwares. So they have different capacities and etc. to calculate all these things. Right? So this is the way you can calculate all such properties and can make the use of this thing. About PKCSM, I have seen a particular paper with me. So that paper has really given a good motivational to me. So I'm going to share that paper with you people. This is a paper basically which is published, let us say, in ACS Omega. Recently, I think in 2020, yeah, it was available online in the month of 2020, February. So this is where they have utilized basically PKCSM and have tabulated all such properties. Kako2 permeability, intestine cell line, VDSS, volume of fraction, P glycoprotein substrate, Lipinski properties, all these properties they have calculated. And basically and boiled egg model, which is one of the good model to predict the brain intestinal permeability. Maybe it was developed by some other leader. Remember that it has nothing to deal with the boiling of the egg, or it has nothing to deal with the eggs. Why it is called as a boil? Because it was developed by scientists whose name is, sorry, not the name of the scientist also, because it deals with, sorry, she made two names of scientists and I forgot to discuss that with you. I shall just show it after some time on, it may not be here, but let me first show what is this. So basically here they have calculated all such parameters which we required for our purpose of this one, right? So ACS Omega paper is this. The same I will repeat it. You can go through the same one. ACS Omega 2020, volume number 5, page number 6021. Okay, so this is one of the very good paper which highlights the importance of the Swiss ADME and PKCSM tools for your further reference. Yeah, I was to tell you the name of this boiled egg model, and boiled egg model ka jo full name has it has nothing to deal with the boiling, it has nothing to deal with the egg. Why it is called egg? Because the shape which is generated, it is basically having this egg shape. That's why it is called as egg. And why something called this boil? Because it is from the name of the scientist. Sorry, not name of the scientist. I forgot to tell this to repeatedly to you, but pardon me for the same. It is brain or intestinal estimated permeation method. Brain or intestinal estimated permeation method, which is developed by these two scientists, Dina and Zotte. And this is published in Journal of Chem Medchem in the year 2016, and it is open access article. You can access this in Chem Medchem 2016, volume number 11 and page number 1170. Okay, so that was the basically discussion I wish to show it to people For whatever the compounds you have, you are interested in calculation of ADMET properties, you can make the use of mole inspiration and this PKCSM and Swiss ADMET for your purpose of calculation of ADMET parameters, Lipinski filters, and this shall be more important to you when you will be designing the new compounds. So with this, we are going to stop. We shall be continuing our discussion on several other topics related important to us. Thank you, everyone.